Hello, and welcome back. In the last video, I covered the install of StreamDiffusion. Now that we're all set up, we've got our virtual environment installed and all the Python requirements ready to go. This video is going to be all about ControlNet. I'm going to cover kind of what it means in general, a little bit of theory behind the research of it, and showing examples of how to balance the settings in real time within TouchDesigner. The ControlNet research paper came out in early 2023, only 6 months after the first version of Stable Diffusion was released, but the technique has been able to be applied to all of the recent image diffusion models such as SDXL and Flux. Generally speaking, ControlNet is a technique that greatly improves the precision of image generation by adding a control image that is used almost as a blueprint of sorts to guide the image generation process. Each ControlNet model is trained using a large dataset of image pairs, anywhere from 50,000 to a million or even more. Each pair contains an original image and a control image. The control image is a simplified or abstract representation of the original image, like an edge map or a normal map. During the training process, the ControlNet model learns how to pick up on how these features in the simplified control image relate to the final detailed original. But during the generation process, only the simplified ControlNet image is what is sent and seen by the ControlNet model. The ControlNet model then passes those features to the main Stable Diffusion model as guidance, and along with the text prompt, the model uses this combined information to influence the final image output, allowing these simplified features in the control image to push towards the desired output while still following the look and style of the text prompt. There's also a weight value that can be adjusted to influence how much the ControlNet features or conditioning have during the denoising process. A higher weight increases the control image's influence, while a lower weight gives the base model and text prompt more freedom. Now let's look at a few different types of ControlNet models. The ControlNet models are typically named after the image filters or preprocessor type that is being used. You've got several types of edge detection models, such as CANI and HED. The edge detection models are especially handy for enforcing the general shape and exact contours of the entire image. There are also pose estimation models. These use images of the open pose skeleton as the input. Each joint and bone have a specific color, which allows the model to know exactly what the pose of the character is, but it doesn't enforce that shaped pose on the rest of the composition of the scene, allowing the ControlNet to focus only on that character's pose. There are also depth map models, which are trained on the original image and depth estimations of those original images. This is great for enforcing the spatial composition of the scene or some sort of three-dimensionality that you would like to capture. There's also scribble and sketch models, which are quite similar to the edge models, but perhaps allow for the ControlNet image input to be a bit more abstract or rough, as there might be a looser relationship between the exact contours of the control and the output image. And finally, the last one to just briefly go over here are segmentation ControlNet models. These are trained on images paired with segmentation maps. Each model type is trained on a list of specific classes that correspond with the colors in the segmentation maps. These can be super powerful, but it is limited to the classes that the model was trained on. So you might want to do research on that data set to see what concepts you will be able to use and work with. There are other types of ControlNets, but these are the most common. It is also in theory possible to train your own ControlNet, but like I mentioned, the amount of training data needed is a lot. Recommended to be at least 50,000 control/final image pairs, so just keep that in mind. But now let's go into Touch and look at how to use ControlNet with StreamDiffusionTD. I'm going to mostly cover how to load different model types so that you can get started testing, but I will also build up some simple setups and dial in the settings to show how to approach balancing the influence of the control image with the prompt. Here we are back in the file. Briefly, before we actually get into ControlNet, I want to really quickly show how this DotUpdater works. This is useful for updating any of my operators when it's currently within a project and perhaps there is an older version that you would like to update. I know I just released 2.0, but I fixed some things and also, ironically, slightly upgraded the install page right after the install video, but whatever. I'm going to drag this new version in and it's going to pop up saying that updating is recommended because there is a 2.2 talk, so I'm going to hit update. say, okay, it's successfully updated. And we're going to notice that all of the settings are still the same, but it is now the 2.2 version. Let's see what this error is. Yeah, there seems to be a parent shortcut error sometimes. I will get that fixed, hopefully by the time that you are seeing this video, but if you do, refreshing the operators or just viewing them and then looking away from them seems to fix that. But yeah, that is the DotUpdater. After you are done updating, you can just kind of close that. And let me turn off V2V for now. And now that we're back here, we're going to go into the ControlNet settings. All of the ControlNet settings are under the ControlNet parameter page. In order to have ControlNet accessible when you are using StreamDiffusion, you'll need to have this toggle on before you start streaming so that it loads the pipeline with this model in mind. After you are streaming, you are able to turn this on and off and adjust the weight in order to get the balance correct. You'll notice that this ControlNet model has a couple different options. This one that is the default is download ControlNet. This will automatically download different ControlNet models. This dropdown is where you'll find those models by the preprocessor type. The other options here are select ControlNet file. So if you have another file local on disk, I'll show that later. And the select folder to create dropdown, you'll want it to be the default parameter. If it isn't set like that, you can right click and hit reset parameter. It should be set, let me just double check. That should be set if you drag a fresh one in, but perhaps if you update from a certain version, that won't be set. And that is fine because the updater is supposed to keep all of the settings that you have on the parameters. Unless that's a new parameter, it won't change the settings. Now that I have this folder selected, we'll see nothing in this dropdown, but very quickly, let's go SD Turbo with the HED ControlNet, which is like an edge detection. So we'll see StreamDiffusion popping up here. We will see that it is selecting this ControlNet model with a weight of 0.5. And now that it's loading, it's actually going to be downloading this. And it's going to download it to this folder. Now that it's downloaded, it's loaded, it's loading the SD Turbo, and you can see ControlNet is active, streaming active. And we pretty much have the same setup that we did at the end of the last video. You are, like I said, able to turn on and off the ControlNet weight, but this won't make much of a difference without anything going into this second input here, which is where you put all ControlNet inputs. So I downloaded the HED, which is like an edge processor. So let's drop an edge, plug it in here. You could also dial in the settings a little bit. This perhaps could be useful to maybe make the background a little less noisy. Whereas this, you can see the bokeh's going crazy. It would be more useful, however, to bring in any sort of recognizable imagery, such as our favorite default movie file in banana. Obviously, this prompt has nothing to do with a banana. If we were to say crystal, that might make a little bit of a difference, but doesn't really look like it. Maybe we'll come back to the banana. Let's maybe think of something that would work a little bit better for this. Flowers. Okay. And as we drag the ControlNet weight, you can see there's a certain point where it really starts to do way too much. And without it, we're still getting the kind of that image input just with image to image, but maybe this is a good balance. If we want kind of this full freedom for the most detail, but still a little bit of the placement of the actual bouquet, just a little bit different. Going to move this stuff over here and select it all and collapse selected. Not sure what's going on with these wires here, but we've got out one here and out two here. Just make sure that out two is going to the ControlNet. And I guess I'll just call this little example. And cool. I'm going to hit the unload model pulse, which will keep the server active, but the model will be unloaded from VRAM. And we're going to move on to looking at the depth ControlNet. And I guess I'll just hit start stream with the depth ControlNet. You can see it downloading here. Let's look at the Hugging Face repos that it's actually pulling the ControlNet models from. For SD Turbo, which is a 2.1 base model, you can see a couple of the examples of the preprocessor inputs, like an edge filter or the depth filter, or just the skeleton of the person in the image, or a little color palette. And for the 1.5 models, it's grabbing from this repo. Now that we have the depth loaded, let me put some nulls so we can see what's going on, even though I just collapsed it, but these can be kind of our viewers for the input and the ControlNet. And now, if we pump the ControlNet weight for this, we get a different type of crunchiness that is not something that you would want, but you can see that we definitely have a different model loaded. Let's bring the edge example down here and bring the palette out and go to everybody's favorite Particles GPU. I believe it's in the, I think it's in the tools. Tools, Particles GPU, yes. You can also search for it if you have the search palette installed. I got this through using Function Store Toolkit, which you might notice up here. You can also get those here, and you can support him here. And we're just going to do a couple things to quickly get a 3D scene in here. Let's add our own camera. In the render settings of Particle GPU, drag the camera in, and that's already a pretty good angle there. Let's go inside of the Particles GPU, and we're just going to add one tiny thing into the operator, bring a depth, and drag the render onto it, and copy the out. There is already a different out, which shows the position of the particles. We're not going to use that. We're going to use this first out, which is like the color, and this third out, which is the depth pass. But this doesn't look good. This isn't going to look good if we plug it into our nulls here. Well, it actually doesn't look too bad. You get that downward motion of the depth map. Let's see. And yeah, downward motion is completely coming from the ControlNet input itself. But if we were to get it a little bit more like preprocessor images here, you can see black in the background, white in the foreground, whereas this is actually white in the background and a little bit of gray in the foreground. Let's add a threshold and go greater, and drag the threshold all the way up or close to all the way up so that we're losing some of those objects in the background and we only see a couple in the foreground. And then you want to bring that soften value up a little bit. And now we're kind of getting much closer to the depth map look. We're definitely getting closer to that shape now without it destroying the image as much. See, if we are to disable the threshold and pump that in with a high weight of 1.5, obviously way too high of a weight, but you can still see that it destroys the image a lot less with the depth map looking like an actual depth map. And if we bring this down here and maybe give the image a little bit more input, now we're almost turning those leaves into flowers. Another couple things, let's just line this up so it's in line. To customize the Particle GPU a little bit more, let's bring back our banana. In the material, we can go to custom. And if you drag the custom, this movie file into the custom particle texture, you can see that we now have bananas falling. But they are a little squished, so what I should have done in the first place is drag a null out here. Let's rename this, call it null source or something, and drag that on instead, and add a fit here with fit outside. That way our bananas are not all wonky in the aspect ratio. And now our bouquet of colorful flowers is our banana shaped flowers. And let's go bananas, endless bananas. And now we kind of have a nice little Stable Diffusion descending banana animation. But maybe we're a little far away or these bananas are a little tiny. Bring the view angle of the camera in so it's a tighter angle. But yeah, there's a ton that you can do with Particles GPU. Maybe you want to bring the rotation type so it faces camera. Might look a little bit better. Another thing that you could do is instead of setting that threshold by your eye or by hand, you can take and analyze top and analyze the minimum pixel, which will find the darkest pixel here, and then bring it over into Chopland so we get some data. And we only need one because the depth map itself is a 32-bit mono, meaning there's only one color in there. So we're going to use this R channel as the value of this threshold. So drag this onto the chop here, and it is now reacting to the depth in the scene. You'll notice we get some jittery looks, which might not be good for Stable Diffusion. So yet another thing you can do is, instead of dragging the threshold out here, drag a null and go like that, and just add a lag. So now, and we can, oh, no, maybe not that much, but we can pump the lag value up a good bit so that we're analyzing the scene a little bit, but we're not getting those sharp pops. I wouldn't recommend auto-analyzing the depth like this for every scene, especially if you have a lot of foreground, background movement. This isn't really the best method, but this is good if we, let's say, zoom the camera way out a little bit, and now we're seeing more of that scene. You can see it kind of auto-reacts to the entire scene there. We aren't getting the black in that background, but if we bring the soften down, like everything in Touch, there's many ways to do this, and it's usually best to tinker with it and see what works best for your setup. One last thing that I might have wanted to do at the very beginning of using Particles GPU is change the aspect resolution, or the resolution of the render setup inside, to be a square. You can see the analyze is kind of breaking when it's this tight. We want to see more of that background. Analyze might also be helpful to define a range and then use something like a hold here, so that once you add that, it basically locks the chop channel here, and you can turn on hold last, which basically bypasses this. And then once you kind of like one of the range, you can turn this off and it'll keep that depth range. And one last thing that we can do is actually drag all of these operators and the threshold, right click, collapse selected, and we can call this depth EST, right click, customize the operator. And the only thing that we really want to expose is this hold set reference expression on source. And instead of it being called hold, let's just change the label, which won't change or break the reference, but we'll call it auto analyze. So when auto analyze is on, you can see it's trying to auto analyze the depth. Just wait, and then maybe we'll turn it off when we can see more of those background bananas. You could also expose a variety of those settings here. And also on my Discord, I have a little operator that does roughly the same thing with this, just built out a little bit more. Now that we've got these ControlNet setups, let's maybe add a bit to the prompt. Cloudy, sunset, background. Bring the step sliders up, and really want it to be super cloudy. Oh yeah, the ControlNet weight's too high. Yeah, bring the ControlNet weight, and now we're getting some wonderful bananas descending into the sky, or from the sky, or against the sky. I don't know. That's kind of strange. But these bananas are falling pretty quick though, and we get a little bit of flicker there. Let me show off one other new aspect of the operator, this create synced component. This will create a base that has its own independent timeline via this time component. And I've also exposed all of these settings, and it adds a bit of Python to the callback code in order for this play toggle to toggle on for a single frame every time StreamDiffusionTD receives a frame from the server. So then inside this, you can put content that will be synced with the StreamDiffusionTD component. So if we were to take all of this stuff, except for these null input, and cut and then paste them in here, drag this null to the out, copy and paste for an out 2, we will now see this is the same thing, but the particle GPU is synced with StreamDiffusionTD. The reason we aren't seeing any bananas until just now is because the particle GPU reset itself when I pasted it. But now you can see these bananas are falling much slower, and they are also completely oriented towards the camera. Hey, real quick, jumping in here. This is Future Lyle from the edit zone. A couple of quick things to note about the Create sync component. You can turn this play on when StreamDiffusion isn't running in order to preview the content. And also specifically with this setup, let me make sure that's playing. The Particles GPU was doing that wonky thing where they were all facing the camera but vertical. I am not exactly sure if this is exactly how you would want to fix it, but when the rotation type is on continuous, the rotation speed has some default values, or I don't think they're that, but if you set all of the rotation speed to 0 and then add an LFO or some sort of thing that switches between face camera and continuous, that guarantees that your objects will be randomly oriented. But yeah, that's just a couple things to note that you can preview your content and that little fix on the setup. And just take the bananas out of the prompt. Ooh, that's much more interesting. Now we have banana-shaped clouds. Dial in all of the settings to really get that look where you want it. Turn on V2V. We can see we get that nice temporal coherence in there and don't get as much of that flicker. Let's load this setup with a different model. Let's hit unload model, and instead of using a Hugging Face ID in the main SD model path, we're going to use a local model. This My Model dropdown is only going to list models that have currently been working with the operator, and it also will include a couple with Hugging Face IDs that I've just put in there so that you have something to get started. But let's load a 1.5 base model. So you can see that in this download ControlNet dropdown, some of the models are 1.5 only, some are 2.1 only, and some are SDXS only. This Sketch ControlNet is actually the only ControlNet model that works with SDXS. But let's do a local model instead of a Hugging Face ID here. So if you hit this plus icon, it'll bring up a file selection menu, and you can go to anywhere that you have Stable Diffusion models located on disk. I'm going to go to my Comfy UI folder and go to the models checkpoints folder and grab Photon LCM. This is from Civet AI, which this is also a little bit different because it has the distilled LoRa weights baked in the model. So along with having the full model path to that safe tensor file in the main SD model ID parameter, you're going to want to go to the models page and turn the skip LCM LoRa on. That is because the Photon LCM model has the LCM weights baked into it. And since we're using the download ControlNet, you can keep it on the depth ControlNet. And the last thing that we have to set for 1.5 models is you will want a couple more steps in the step schedule. This will slow the diffusion process down a little bit, but it is necessary for the 1.5 models to get a fully denoised image. And now that we have all of our settings, which was changing the main model SD parameter and turning the skip LCM LoRa on, keeping the depth ControlNet because we're using download ControlNet the same, and then finally bringing it to 4 steps for a 1.5 model and clicking Start Stream. This will then show our new settings, Photon LCM and the ControlNet depth, which is the 1.5 base ControlNet from that Web UI ControlNet Safe Tensors repo that I showed earlier. You get quite a different look with the 1.5 model here. The FPS is a little bit slower. You're using 4 steps. I am running on a desktop 4080 with 16 gigs of VRAM and screen recording, and have quite a bit open in the background, honestly, but you can see now we get a totally different result with the 1.5 model. Depending on what you're going for, you might want to go with a 1.5 model. You might want to go with a 2.1. Maybe I'll do a little bit of breakdown on strengths and weaknesses of both, as well as exploring a couple different options that you have other than the LCM model. But yeah, so that's the ControlNets running with 1.5. Let's go ahead and hit the unload model, freeze VRAM button again, and perhaps if you want to use a type of ControlNet that isn't listed on this page, or in a crazy world, if you had a custom ControlNet or something, you can use the Select ControlNet File option in the ControlNet model dropdown. And this will allow you to select a safe tensors file from disk in order to be loaded as the ControlNet file. You'll also notice that the 3 ControlNets that we've downloaded so far are in this dropdown. But let me just select a file from disk. All right, I'm gonna wrap up the video here. I've got more coming soon on using these tools within your project. Also, a lot of operator updates, and keep an eye out for some new operators as well, including a real-time transcription operator. Also working on getting videos out that explain many new features of ChatTD and working with Comfy UI as well. As always, thank you so much to my Patreon supporters, and join the Discord to share what you're working on and interact with the rest of the community there. I've also got several ControlNet-oriented preprocessor tools that are available on the Discord as well. And I'll see you later.